In this video I'm going to look at how to review data that were measured from PMMA. And the data are a series of measurements that are just repeats of carbon 1s, oxygen 1s and valence band. And the intention of measuring the sample in this way is to observe how PMMA reacts to the measurement process itself. So there's no other intervention such as an ion beam that is causing the changes in these data, but when I overlay the carbon 1s, it's quite clear that changes do occur. The first thing we ought to do is adjust the experimental variable. The initial experimental variable in this file is all set to 0. Typically this would be the etch time, and since there's no sputtering the sample, the etch time is always set to 0. But there is another experimental variable, and if we press a toolbar button that switches the experimental variable, then you can see that rather than the etch time, we now have the index of each measurement. And this serves to separate the different measurements, and that's good. But there is another option that allows us to apply the acquisition time per row. So we can switch from the index for each measurement to the acquisition time that's calculated from each one of the VAMAS blocks. So when I press this button, we can see that we now have the acquisition time in seconds for each one of these experiments. So when we overlay and try to characterize these changes, we at least have a measure of what it is that is causing these changes. I'll now illustrate one way to make use of these experimental variables as part of the display of overlaid spectra. This involves switching the geometry from 2D to 3D. What this means is that we get a stack of spectra all plotted on a three-dimensional plane. We can make some adjustments to the way these are displayed. We can turn off the graph box, that's this exterior box. We can turn off the 3D planes, that's the plane at the back here. I could also go to the y-axis and turn on the experimental variable, and also remove the y-axis scale. So this results in a plot of this form, where we have the experimental variable along the one axis, the binding energy along the other axis, and the data plotted over a plane. We can make further adjustments to this using parameters that are on the geometry property page, and these involve altering the scaling and the shifting of two planes, the front plane here and the back plane here. So if I go to the back plane and make some adjustments, so rather than offsetting in X towards the right hand side by 80% from the center, I'm going to make the back plane the same as the front plane, minus 100, so it'll shift all the way to the left. And then I want to scale both the front plane and the back plane in X the same, so I'll make that 70 and 70. And we can also make an adjustment to the Y scale. We'll make both of these the same as each other. And then we can perhaps move the shift in the Y plane down, or maybe up. And that provides us with a plot from the beginning to the end of the experiment, as described by the experimental variable of the acquisition time for each row in the right hand side.